Welcome back, sawheads. We shall start this session with the automatic oil pump. I'll just briefly go over the operation of this module. So here we have a worm gear, and it runs off the clutch via these 4 splines here, which means that if the clutch isn't turning, then no oil is delivered, and that drives this spinny wobbly thing, hereinafter referred to as the spindle. And so this turns round and round, but then we have this screw, and it has a, is that going to focus? It has a pin on the end, and the pin runs in one of these grooves, here or here. The quantity of oil delivered can either be set to low when the screw is here, or high when the screw is running here. And you can perhaps see there's slightly less wobble on this groove and a bit more wobble on this groove. So these 2 items run in the pump body, and the screws, black screw with the pin, can either fit in one or other of these. The silver coloured screw is just essentially to blank off whichever hole is not being used. This spindle acts as both a plunger as it moves back and forth, and also as it rotates, this flat on the end forms a simple rotary valve. It runs inside the body here, so we have an inlet and an outlet, and these are arranged, if I shine a torch in here, these are arranged so they enter and exit diametrically opposite to each other. And this means that as the spindle is wrong end. So the spindle is up, so it's covering one of the holes and the other one is open. So if it's covering the outlet, say, and the inlet is open, at that point the spindle is moving out, drawing oil in, and then as it rotates, now it's covering the inlet but the outlet is open, and now the spindle moves back this way, pumping oil out. Now the first issue that I've got here is this pin, and despite being hardened steel, this saw has seen quite a bit of use, and so it's worn on the flats here. So what I'm going to do, I need to arrange so when it goes back screwed up, I'd like it to end up being a 1/4 turn away from where it was, which will mean that instead of running on these worn parts, it will run on fresh material. Problem with it being worn is because the pin is a smaller diameter, you've got a bit more slack in here and you'll get less oil flow. So there are 2 ways to do this. This is a 0.8mm pitch thread, so I need to either include a washer of 0.2mm, but what I'm actually going to do is I'm just going to take off 0.2mm off this surface with a file. There's enough clearance that we can drop down 0.2mm further into the groove without causing any trouble. So here we have Roman numeral markings 1 and 2. So with the black screw at 1 you get a low flow rate, and at 2 a high flow rate. And I've removed that 0.2mm from both sides. So now this little pin, when screwed in, will line up very nicely as I want it to on the inside. Now the next thing is, in terms of seals, on the inside here is where the crankcase oil seal goes, crankshaft oil seal, that presses in. On the outside, to prevent the ingress of dirt and dust, we have this seal here, which unfortunately I kind of damaged somewhat in removing the oil seal. And this is extremely unobtainable, so the idea here again is this ring is a press fit in there, and then we have this kind of V-groove arrangement here. You can see the V-groove. I think this was originally far more flexible, but it kind of fits in here, so this edge is inside the V. And then this piece is sized to be a snug fit on the clutch drum here, so this will spin round and it keeps most of the dust out. It's not actually gas tight or liquid tight, but it will keep the dust out. But anyway, this is kaput, so I had to find another solution. I've come up with this oil seal, which is readily available. It's a 25, so it's 25mm hole, 40mm outside diameter, and 5mm thickness, and that's exactly the right size to press in here, but also it's kind of a nice snug but not too tight on the clutch drum here. My only reservation is that I think they, rather than oil seal, they use this for a reason, and I guess if the clutch drum isn't quite centered on the shoes of the clutch, there'll be a little bit of wobble on here, and having this groove arrangement here allows for a little bit of wobble, whereas this will be running directly on the oil seal. So this is another experiment. It will certainly work for the first 5 minutes, and maybe it'll work really great. But anyway, these are cheap as chips, so we'll find out in due course. Meanwhile, it's time to move on to the assembly of this, and I think the first thing to do is to press in a new crankcase oil seal. In preparation for driving the oil seal into place, I've just taped it onto this socket here. The tape will be pushed out of the way as the seal goes home, and I've also just put a bit of smidgen of oil onto the surface in here to help it go in. So I've got it all ready to squash into place, but just to help things go smoothly, I'm going to add a bit of heat into the mix. For good measure, I've got a thermocouple hooked up. Okay, well that's 75 degrees. Let's see how this goes. It's gone in nicely. Nice and flush with this surface here. So it would appear that Husqvarna have left us with a bit of a chicken and egg situation with this oil pump, and we will have to be careful not to end up with a dead chicken and a broken egg. So in order to adjust the oil flow, obviously we swap these two screws over. However, once the oil pump is installed like that, the screws are no longer accessible. So the oil pump has to be removed in order to change the oil flow if you want to run a longer bar or a shorter bar. And that's already getting into the realms of taking things apart a bit too much. Not something you really want to do in the field. But the real problem comes with the oil seals. Now on the crankshaft here, we've got this step here, and the oil seal runs on this surface here, and is the old oil seal. It's pretty worn, but even so, it's not just gonna push on there. You might make it, but the chances are that the seal edges will be damaged. So I've made up this little tapered cone thing here. It's actually a handle of an old defunct soldering iron. That's why that hole's there, but that hole shouldn't affect the operation. That just slides on like that. That enables the oil seal to fit on like that. All very good. However, once we come to install this oil pump as a single unit, we're going to need to have this cone in place like this. But once this is fully assembled, the worm drive must already be in here, which is fine. However, once we drive this seal in, this worm drive cannot be taken out again. It will not pass through this, and it wouldn't have passed through the old one either. Once this is in place, well, I'm not going to feed it through, but I think you can see that there's going to be no room for this cone. It can't pass through this, which means every time you want to take the oil pump off, this seal has to come out of the front to put it back on, which means pretty much destroying the seal. So just to change the oil flow setting requires all manner of nonsense, and we'll need a new seal as well. I don't know if I'm getting all this wrong. If any of you have figured this out, please leave a comment. Still, this oil pump situation is only a minor inconvenience. The factory manual specifies that position 1 is for bars of 15 inch to 21 inch, and position 2 on the oiler is for bars over 21 inch. Well, I'm never going to be running less than 21 inch, so I shall choose position 2 when I assemble the saw. But right now I'll do what I can to put this together. So we've got the spindle here, then we've got a bronze bushing at this end, and this little plastic plug, sealing plug, at the other end. So this I've already put on some moly grease just in the slots and on the end. We'll need some here eventually, but that can be done at final assembly. So I'll just pop the bushing on here. Then goes down in here. And then I should just be able to tap it home using this as a drift. I think we're going to have to get Mr. Vice to complete this task. Here's Mr. Vice. So we can just pop it in like this. I think that's got it. Now it's time to fit this little plastic plug. It just pushes in to the end here, but before we do that I'm just going to put in a little drop of ordinary engine oil just to make sure it's lubricated right from the get-go. And it's just a matter of push fitting this little plug. Presses in like that. Found the way to get that plug out. I just used a Stanley knife just underneath the shoulder to lever it out. So I've installed the 2 screws, the black screw in position 2. Now you can see when we rotate the spindle, it moves back and forth like so. Well, my goodness me, so much waffle, so little action. But I did warn you at the beginning it was going to be excessively detailed and quite a tortuous journey to the end. Or perhaps you've completely mullered your dopamine receptors with AI slop, and this is a welcome bit of slow TV. So as this video draws to a close, I shall randomly put this down, grab a flywheel to do this with, as I say, thanks for watching.